Hi everyone, this week we will learn object-oriented programming. I am Dr. Muhammed Gölec from Boğaziçi University Computer Engineering Department. By the end of this chapter, you will be able to define and use your own data types through classes and objects, understand how to transfer and manage data within and between classes, recognize the importance of class-based design in large-scale software projects, create and use methods and operator overloading for custom data manipulation and comparisons, apply inheritance and to reuse and organize your code efficiently. Okay, classes allow you to create your own data types by bundling data, it means attributes, and behavior, or we call methods, together. A class is like a blueprint for creating objects that share the same properties and functions. Objects are instances of a class. They store unique data while using the same structure. And the underscore init method initializes object attributes when an instance is created. Using classes helps organize code, make it reusable, and follow object-oriented principles. Here, you can see the main skeleton of a class. First of all, to be able to define our class, we have to use class keyword and then your class name. And here, underscore init underscore called instance methods. We are using that one to appoint attributes, values, or variables. And here, some underscore method, our instance method, or we can call them as a behavior. And again, attributes here. And update underscore parameter, again, another method, behavior, with an argument. And after defined our class, we are creating or defining our object by writing class name and then two attributes inside of initialize function here. We are writing just here, right? And we call this obj variable as an instance or object. Okay, we can start with real example. Here I define a class with 1 and 2 different behavior or methods, and it's gonna take 2 different attributes, and I'm using initialize function here. And don't forget, every time either initialize function or any other functions, we have to put self keyword, right? It is for calling our object. It is a rule, don't forget it. And now after defining our class, we can create our objects. Again, it's my class name, and I'm sending 2 parameters. Then to be able to call my behavior, I'm writing object dot some underscore method. So if you can check this part, it's going to return our parameters, right? But if I call other behavior, other function, it will update the parameter 1. You can check this part. Let's go to Anaconda and see. Okay, again, I define same class here. Then I'm creating an object called obj here, and then I will call the functions by turn. And we can continue with different example. Let's say we have a class with a student and his name is Bully, and I will write a class and I will give him his name, and once I call the behavior, it's gonna print hello, I am whatever I just put here, right, as a name. Okay, here you can see my class. Again, I use class keyword. I give a name to my class. Then I write here initialize function to be able to get my attributes. This time I just have one attribute, it's name, right? To be able to appoint name attributes, again, we are using self.name equal to name. And to be able to create my behavior, again, I'm using def and my function name and self keyword, right? Then it's gonna print the student name here. Okay, after creating our class, I can create my objects. I will say S1 and I will write here class name and my attributes. It is his name, right? Bully, the student name. Then if I call my function or its behavior under my class, I have to write my object name and dot and the function, right? Then after that one, it's gonna print hello, I'm a bully. Let's go and see. Okay, first of all, I create my class, then I create my objects, and I will call my behavior. Now we can make this example a little bit complex. This time it is like CMP, our module. We will give student name, student midterm 1, midterm 2, and final exam scores. Then to be able to appoint these values, again, we are using self.name, self.midterm, self.midterm 2, self.final exam attributes, right? And this time I want to calculate student average score. So I will take 30% from midterm 1, 30% from midterm 2, and 40% from final exam. Don't forget, every time, whenever I want to use class attributes, I will call them by writing self.midterm1, self.midterm2, self.final exam, right? So our special keyword under classes is self. Never forget. Even you don't put any argument inside of your function, like here, still we have to write self, right? So you never make blank your brackets in your function like this. Always put self here. Okay, then after that one, I create one more behavior. It is display underscore information. If I call that one, it's gonna print student name, student midterm 1, 2, and final exam grades. And also, it's gonna call other function. It means calculate average. And it will calculate average score, right? So again, to be able to call another function under one function, again, we are writing self dot. Then we are writing other function name. Okay, then I just create my objects by using my class keywords and student name, student midterm 1, midterm 2, and final grades. Then once I run this behavior or call this function, it's going to calculate the average score. Okay, let's go and see how it works. First of all, I create my student class here, as you can see, and I create my objects by using student name, midterm 1, midterm 2, and final grade. Once I run it, it's going to calculate the average score like that one. Okay, and after define or create my class, and if I write print and my object name here, it's going to show us this object's class name. If you remember, if I write print type integer, it was showing sorry, if I write here 5, 6, 7, let me remove it. Let's say 5. It was showing this object class. It was integer, right? If you remember. So it is likewise. Even I don't write here type function, just only object, it will show the class. It is student class. And one more extra information to, if I create an object like in the previous pages, and if I write print student1, it was supposed to see the class, right? Class name. But I can change that one. Let's remove it. If I want to customize, if I want to change my print predefined function under my class, I can use representation. Let me explain more. I just want to, if I write print my object name here, I want to see all informations like student name, students, maybe average score, instead of class name. I can go to under my class and I can use representation function here. Then I can change it. I can customize it, right? Let's go anaconda and see how it works. Okay, first of all, if I created my class, same class, I didn't change anything. And if I create my object here, and if I write print student1, I will see student class name here, right? But I want to see student name and student average score instead of that one after writing print. So we will use representation function here. I didn't change anything until here. And I add one more extra behavior here, right? To be able to do it, I will use 2 times underscore and representation underscore and self. And I will return student name and student's average score by using the function of calculate average, right? I run it. I created my object here again. And this time, if I write print student1, it's gonna show student name and average grade here. And also in object-oriented programming, we have inheritance. A class inherits the attributes and method of another class, and the purpose is reducing code duplication, abstract common behaviors, and establish a hierarchy. To understand better, we can give an example here. As you can see, cat and dog under the animal family, right? So here, animal our superclass, and cat and dog our subclasses. I will explain a little bit more by giving examples. Okay, let's say we have our superclass here and subclasses here, right? And to be able to take inheritance from superclasses to subclasses, we are using barrack rates and superclass name here. It is animal, right? So I define my superclass here. I define my subclasses here. And after writing class and class name, I have to write my superclass name here to be able to inherit some attributes and behavior from my superclass. Also, in terminology, they call these classes like superclass, parent class, base class, or they called subclass, child class, or derived class. But in this module, I prefer to use superclasses and subclasses, right? Okay, again, same example. Here we define our superclass and subclasses, and we are taking inheritance from animal. And if I create my object under dog class, and I give name as a Karabash, Even dog class, if you pay attention to this part, even dog class doesn't have any attributes, any functions, any behavior. Still, we can define it by giving attributes and it's gonna work because it will take initialize and other function behaviors from superclass. It means here, if you can pay attention to that part, right? If I give Karabash, it will first of all go there and it will take all attributes and behaviors inside of that one. It will write here Karabash and it's gonna point it to name. And if I write, okay, after defining my dog object here, and if I write pet.speak, what you're supposed to see here? Because in the first, if you have a look at your dog class, we don't have any function, right? We just have none. But here you try to call one function. How? Because of, again, superclasses. So subclasses can use all attributes and functions under superclasses, right? If it takes some inheritance like that one. Okay, let's go to another code and see. Again, I created my superclass here and subclasses. I'm writing my superclass name here to be able to take all attributes and behavior. And if I define a class, if I define the object under dog class and speak, and it will go and take superclass attributes and behavior. Also, we have overrides in object-oriented programming. It means redefining a method in a subclass that already exists in the parent class to change or extend its behavior, right? And it allows different subclasses to provide their own specific implementations of the same method. To understand better, again, I will give example here. Again, same example. It's my superclass here. It's animal. And I define 1 and 2 subclasses, dog and cat. As you can see, again, these two classes taking inheritance from animal class. So it means these two classes can use any behavior and attributes from animal class, right? And in animal class, we have initialize function and one function called speak. But what if I define one more speak function under subclasses? And if I define one object from dog class like pets, and if I call pet.speak, my question is, it will take this or it will run this speak function under dog or under animal? The answer is it will run this code under dog. It means that one, right? We call it override. It means we have same name, we have same function with the superclasses in subclasses, but we are changing its attributes. For example, in animal class speak function, it is just return silence, but in dog class speak function, it will return the wolf, or in cat class, it's gonna return meow, right? So we can go to Anaconda and see how it works. Again, it's my superclass. These are my subclasses, and I'm taking inheritance, and I'm overriding speak function. As you can see, the speak function under animal return silence. the speak function under dog return woof, or how do you call that? Well, I don't know. And in or under cat class, speak function return meow, right? So if I create a dog, okay, let me create one more. Maybe I can say cat1 equals to cat class, and I will say ticket like this. And let me print also cat1 speak. Okay, here I create an object under dog class called pet, and I created an object under cat class cat1. What if I print pet.speak? And what if I print cat1.speak? Okay, can you see the difference? Even I call same function, they are behave differently. Even you can say animal1, animal, let's say feed this time. And if I print these objects animal1, as you can see now in the last example, last object, return totally different. Okay, I hope they are all clear. And again, here we have one more example for overrides. We have superclass as a vehicle and subclass as an airplane, and it takes inheritance from vehicle class. And again, as you can see, these two classes have same function, move and move. In the first class, it returns the vehicle moves. In the second class, it returns the airplane flies, right? I will create two different objects from these two different classes, and I will call them. I will call their function, like move and move, and you will see they behave differently. Okay, likewise, also we can do multiple inheritance, like, if you but bets animal, right? An animal under animal, walker, and flyer classes. So bet class can take multiple inheritances from this class, and this class. It means bet class can take or use all attributes and functions, behaviors under these three classes. To be able to explain better, I will give an example here. First of all, I will create 1, 2, and 3 superclasses. It is animal, walker, and flyer. As you can see, animal have a function called speak, and walker and flyer have functions called move. But under under walker class, the function move return walks on land. Under fly class, the function move return flies in the sky, right? And here, my subclass bats inherits from animal, flyer, and walker classes, as you can see. Also, it has speak function, and it returns this word here. After defining my old classes and inherit it, I can create my objects under bat class. If I print, my object that speak, it's gonna print screech. It means this word, right? It will come from my own class here, not animal class. We call it override, if you remember. And if I call move function, it will take it from fly class instead of walker class, right? Why? Why it takes move function from flyer class instead of walker class? Because in Python, it applies to method resolution order. when there are methods with the same name. So it's gonna take the last class, right? It is flyer. And we have one, okay, before continue, let's go to Anaconda. Okay, it is here, multiple inheritance. I defines three different classes, superclasses, and my subclass here. I run it. I will create my object from bed class, and as you can see, it's working like this. And we have super function. It means predefined or built-in function in Python that allows a subclass to call method or constructs from its parent's class. It helps extend or reuse parents' functionality instead of completely replacing it during overriding. Okay, let's start with example, then you will understand much better. Here we have one superclass. It is animal, and it has initialize function and one behavior speak. And here we have subclass, as you can see, it is dog. And the main difference here, if you pay attention, initialize function, because animal class just has one attribute called name, but here initialize function has name and breed, so two different attributes, right? So instead of writing here self dot name equal to name, I will take it from my superclass. I mean here I'm calling my superclass initialize function. Just think, for example, if my superclass animal has maybe 1 million different attributes, name, surname, city, age, and blah blah, it's going like this. And if I write it here, self.name equal to name, self.surname equal to surname, self.city equal to city, and if I need this all information one more time under my subclasses here, instead of writing, all together again, self.name equal to name, self.surname equal to surname, I just call my superclass initialize function. Then I will just write here only differences like breed. So I will gain time, right? And it will be less complex coding. So likewise, also in function definition, if you can see here, speak under my superclass just return silence, but speak under my subclass here, it will return the same result from superclass, and plus it will write here the name. I hope you understand much better now. It means even we can call the function from superclass by writing super, right? So after defining my old classes here, I can define my object from under dog class. I will give Karabash its name, and I will give its breed. And once I run it, it will call this cp function from dog class, right? Let's go and see. As you can see, once I create my object under dog class, and once I call the function, it will come here, first of all, and it will run the function under superclass. It means this part, right? It will take silence. Then it will edit here silence plus then the name. It means Karabash and says move.